Very much. Hi, everyone. My name's Nigel Bayliss. I'm the product manager for the Oracle Optimizer. And before diving in, firstly, I'd like to thank the organizers for giving me the opportunity to speak here. Secondly, you can see that I am aiming for the award for the longest presentation title in the world. Not the longest presentation you'll be glad to hear, but I think Doag has got an 80 character limit or something. So this kind of freedom's gone to my head a little bit. And I'm upset that video's been disabled slightly because I'm wearing my special lockdown beard now because we're all in lockdown here, as I'm sure many of you are as well. So let's dive in. So draw your attention to the legal bit, typical Oracle policy there. Just bear in mind that not to base purchase decisions on what's in the deck. So the content in this deck is relevant to Oracle database 11G onwards. So I can be specific about that. It is relevant for Oracle Exadata, autonomous database, and on-premises deployments. It's not prescriptive or necessarily best practice. The aim here is really food for thought. And it's probably it is most relevant to environments that largely use repeatable SQL. So that means SQL statements that use bind variables, or perhaps you're using force cursor sharing, something like that. So it's really relevant for those kinds of environments. Sometimes I'm going to use the phrase autonomous database, but that's largely shorthand for ADB and Exadata features. And I'll probably look at the chat at the end, but if I catch something on the way, I will try and answer it then and there. But generally speaking, I tend to notice them right at the end. The other thing I want to mention is that feedback is strongly encouraged here because the content in this deck is going to form the basis of a blog post that comes up and presents these ideas in here. So if you want any kind of input to that, then get in touch with me. I'll show you how at the end. But yeah, get in touch with me because this is something that I've been working on for some time and really taking inputs from as many different sources as I possibly can. So I'd be definitely interested to hear your opinion on it as well. So this is what I'm going to talk about. So for the first part is it's a brief section on how we repair SQL performance regressions in the Oracle Autonomous Database. And then I want to touch on a feature or a facility now that we're providing in Oracle 19c that you may not be aware of yet, which is the automatic SQL tuning set. I've called it the running set for some reason, but it's the SQL tuning set. I'm then going to look at SQL plan management and how it works and how it's used in Oracle 19c for non-ADB and non-Exadata, and then on to SPM pre-Oracle 19c and how you might want to use it. And then the payoff really is what this is about, is repairing SQL performance regressions quickly. And I'm aiming this at non-ADB Exadata. So this is for, existing deployments that you have on premises, for example. So really the idea is really what can we take from the way autonomous database handles performance regressions? What can we learn from that? And then how can we apply that in, for example, a non-autonomous, non-Exadata style environment? So very briefly, I'm sure you're all aware, SQL plan management has been available since Oracle Database 11G. And the purpose of it is to enforce SQL execution plans and prevent query regression. That's, if you like, its primary use case is to prevent any performance regressions at all. And the idea behind it is that you have approved, if you like, SQL execution plans that are held in the form of SQL plan baselines. The other nice feature about it is that you're not fixing execution plans in stone, that as schemas change over time, or as the data distribution, for example, in the database changes over time, you can use evolution, the process of evolution, to figure out how plans should change, and if they do change, then validate the path in which they change over time to prevent regressions from happening at all. So I guess I generally refer to that as the strategic or the proactive use case, where essentially you've captured everything in the database, all your SQL statement plans. The idea then is that you proactively prevent query performance regressions, and then any plan changes are then tested and evolved in. There is also the tactical or reactive use case, which is extremely common, of course. So I think I encounter, for example, DBAs very frequently that use the tactical and reactive use case first and foremost. That's the one that seems to be perhaps the most common. And the idea there is that you use SQL plan management as a mechanism for, if you like, controlling critical execution plans or specific parts of the workload. So in other words, you kind of concentrate it on small areas inside the database, small particular SQL statements. So let's take a quick look at Oracle Autonomous Database and what it does. First and foremost, it automates the tactical approach, the way of detecting and repairing performance regressions rather than the proactive approach. Okay, so that's the key fundamental principle, if you like. The way that that's enabled is there's an auto mode. So again, this is available in Oracle Autonomous Database and Exadata, where you set auto for the auto plan source and the auto plan baseline, which is a SQL plan management API setting. If you set that on, then the auto mode is then enabled. And the way that it does this is we introspect AWR and ASTS, which I'm going to come to in a minute. And we introspect these sources of execution plans, and we select the ones that are consuming significant system resources. So as I mentioned, I'm going to come to ASTS in a moment. Once we have targeted specific SQL statements that are consuming a lot of system resource, we can then go and look for alternative execution plans for those particular SQL statements. Because really the big thing is maybe an old plan is better than the new plan. So this is, if you like, the key performance regression use case where everything has been fantastic, for the past 12 months. And now that you have a SQL statement that is suddenly not performing. And in those kind of cases, you can usually expect, of course, that there's an existing plan in a repository somewhere, and that execution plan is potentially better than the one that you currently have. The key thing here as well, just to bear in mind, is under those circumstances, the previous plan might be fantastic. You've got a plan that works really well, and it may never have appeared in AWR. So we need, of course, to cope with those kinds of use cases, which is again where we have this other thing, the SQL tuning set that I'll cover in a minute, that copes with that scenario where you have an execution plan last week, which was so good that it never actually featured in AWR at all. However, this week it's suffering from a performance regression, but now we need to go and find that plan somewhere, that previous plan. And that's really the basis on which we build upon, if you like, the idea that we track previous plans, essentially all of them. So really a summary picture of this is that we inspect AWR and this SQL tuning set that we maintain, and we look for, if you like, the top SQL, loosely speaking, the SQL that is consuming significant system resources. And at that point, we go and find alternative plans. And we look inside the SQL tuning set for the plans that we've seen over a period of time from that particular SQL statement. We then add that to the SQL plan management, SQL plan history. So in other words, we take those plans and we gather them together and hold them in SQL plan management. At that point now, we can evolve them and test one plan against the other. We can actually now, if you like, set off a series of test executions in the background to pit one execution plan against another to figure out which are the better execution plans. The plans that are proven to be better we're now in a position to say, these are the plans that we want, or the plan that we want, and we'll now add that to the SQL plan baseline. So essentially what we do is we say, these are all the plans we've got, which is the best one. Let's accept it. And then we accept that plan. And then those plans are then used to constrain the SQL statement when it's executed next time. So now when the SQL statement executes it again, if we did discover that the previous plan was better, we are now in a position to tell it to use that execution plan. So really, in summary, in Autonomous DB, this process is something that happens all the time. So it's something you don't, of course, need to particularly involve yourself with. It just happens. So in summary, in autonomous database environments, SPM proactively prepares SQL statements, performance regressions. The way that it works is high resource consuming SQL is stored in the SQL plan baseline. So in fact, you can see in DBA SQL plan baselines as accepted equals no. So it's not accepted yet. We then compare the performance of the different plans using SPM evolve, the evolve process that you may have already used in the past, the mechanism in which we can test one plan against the other. Then the winning execution plan is accepted and becomes an accepted SQL plan baseline. And that then plan is then used by the SQL statement going forward. In autonomous database as well, we do have a high frequency SQL plan management task, which executes, I think it's every 15 minutes or half an hour or so. So it's a process that is designed to happen much more frequently and, if you like, outside the normal maintenance windows, so that we can repair these kind of regressions much more quickly than we would otherwise. So that's a summary really of what autonomous DB does. So what can we learn from that really, and what can we use from that as well? That's really, I think, the big question here that I want to answer. So before we get into the details of what you can do with this kind of infrastructure, let's take a look at the automatic SQL tuning set. So this was made available first in autonomous database. It is a SQL tuning set. It's simply a SQL tuning set that is maintained by the system. So what we have in autonomous database is a task that executes very frequently and takes SQL statements and plans from the cursor cache and stores them in a SQL tuning set. So the SQL tuning set name is actually sysauto_sts. You can see the statements. They appear in DBA SQL set statements, just as you would expect. This task itself, it's actually part of a different framework from the normal auto tasks that you used to. And that's because they execute more frequently than the usual kind of auto tasks, which are often designed to run inside maintenance windows, for example. This task is something that is designed to run frequently. You can see details of it if inside these views. And in fact, these views are not currently documented, but they will be. The plan is to document these views so that you will see them, but right now you're not going to see them in the documentation. I'll talk a bit more about that in a minute, actually. But anyway, so the whole point of the system tuning set is that it's meant to be self-managing. The idea behind it is really along the lines of autonomous in general, and the idea is that it should be on or off, and that's it. So you can enable and disable the task itself. The task instantiates every 15 minutes and it retains statements for 53 weeks. So we basically keep a year-long history of SQL statements and their execution plans. We'll talk a little bit more about that in a moment. There is a mitigation built into this, a soft limit, if you like, so that we don't, for example, if you have a SQL statement that is fully dynamic, you have in it, a predicate with a written in value into the SQL statement rather than a bind variable type SQL statement. We do limit duplicates of those, and we use the force matching signature to do that. So in other words, you don't flood the SQL tuning set if you have a system that just generates loads of different, essentially it has a model SQL statement and then it's pushing literals into predicates. We don't capture every single literal that goes by, of course. I think when you see this initially, you think about what about the resource consumption, the space that it consumes. I've got some information on that coming up, but it's very visible. So if you're in any way concerned about it, or you want to measure it, you want to test it, any of those things, if you look inside the doc ID I've referenced inside for MOS, it will show you how you can look at those kind of details. So if you have concerns about resource consumption, etc., it's inside that MOS note, so you can take a look there. So just a little bit more history behind it. It was created originally to support automatic indexing, because automatic indexing very much depends on the ability to test execution of SQL statements from your workload. So in fact, what we do in the background is when auto-indexing was conceived, we had included this mechanism by which we gathered workload SQL that we saw, store it inside the SQL tuning set, and that was used then to test the effect of indexes when we create them, essentially we create them and then test the workload against those indexes to see whether the indexes add benefit. So that's where it came from. And then in release update 19.7, it essentially became exposed as an infrastructure component. So it became visible at that point. It was there, but it was not something that was really on or visible particularly. But now we need to address the sort of dark side of this a little bit, I think. And that was the fact that this was a surprise, I think, in 19.7, because it was on. If you keep up with Mike Dietrich, I'm sure most of you do, you will have seen the unexpected surprise blog post. And actually to address that in more detail, there's now a note that covers specifically exactly why it's there, what it does, its resource consumption, how you can see that. So it is in fact now, because of the feedback we got in 19.7, it's now off by default and available outside of ATP ADB. So if you're using ADW or ATP, it is on by default. If you are using it elsewhere, like on premises, for example, it's off by default. But you can use this feature in Oracle Enterprise Edition, for example. It doesn't need to be autonomous and it doesn't need to be Exadata, and we'll be clear about that. Obviously, you always have to check the licensing guides for the source of truth on this, but that is the current position with this release. So for latest RUs, so if we look at, say, 19.8, it's off by default. Okay, so the feature is there. You can use it, but it's off by default. More on that is in the blog post. So hopefully, if you want to dive into the detail about this, it's all there, and you should be able to start at the blog post and delve into the MOS notes and so on. Okay. So let's look at the co-host has asked you to start my video. Okay. Hello. I hope that's not too frightening. Anyway, so if we look now at SPM in non-ADB Exadata for Oracle Database 19C and onwards, this is for non-ADB Exadata environments specifically. I'm not excluding those, but if you've got an on-premises environment, now consider the significant advantage of keeping your workload query plans in the automatic SQL tuning set. So that's the key thing I want you to think about. This enables you now to be ready to repair SQL's performance regressions, the plan-related ones at least, when they occur. I'll show you a little bit more about that in a minute. So the key thing is, if you like, the key step is if you're using Oracle Database 19C, don't be too quick to dismiss the automatic SQL tuning set. I think the key concern I hear from using it is, What about the space that it uses? What about the resource consumption it uses? So again, the MOS note gives you details on some of this. It's very difficult to be entirely specific, I must admit. So what you find when you look into this is that, you know, it's obvious really that different systems have very different types of execution plans. And of course, what we're doing, we are storing an execution plan, and some execution plans are bigger than others. So I think the general, you can guess, generally speaking, what you're going to see is that, you know, if you've got a DSS style environment where you've got big queries, you tend to have maybe fewer individual queries, perhaps, but the plans are large. For OLTP environments, you could have hundreds of thousands of different SQL statements, but the plan's generally a little bit more index driven, a little bit smaller. So one thing I did find when I was looking at this is that there's a big spread of space usage. I think, you know, typically we're looking at the region of something like 1.5 GB in sysorgs consumed by ASTS. But, you know, I really want to emphasize to treat these numbers with a pinch of salt. But I did want to give you something to give you a kind of order of magnitude feel for this. So, you know, I did look at some specific systems, for example, and here we've got a case where, you know, there's something like 12,000 SQL statements, an OLTP style environment. So we're looking at about 45K a statement, that kind of area. I think I've heard of some, I think the largest kind of systems I've heard of so far are in the region of 4 to 5 gigabytes, that sort of range. So, you know, it is a reasonable amount of data, but I think in the scheme of things, it's not a huge amount of data. Well, that's my premise here, that you should consider it as a possibility, because I think the payoff of doing this is so large. And this is really what I'm proposing to you. And again, asking for feedback. You know, if you don't buy this, if you think this is a ridiculous argument, I do want to hear from you if you think that this isn't the case. Because our belief is that the cost of maintaining the SQL tuning set is outweighed by the benefits that you get down the line for dealing with performance regressions, which that's the next thing I'm going to cover. So I'm going to cover that in a minute. So let's look at pre-Oracle Database 19c. So you're not at Oracle Database 19c yet. Well, you can still create SQL tuning sets. So you don't have the system maintain one, you know, that's automatically doing this stuff, but you're in a position to load it yourself if you need to. There actually are some differences between ADB and non-ADB here because of backports and things, but let's just stick to the sort of simple case. So SQL Plan Management Capture, of course, is available to you. And in fact, from Oracle Database 12.2 onwards, you're able to filter that. So what that means is that you can set auto capture on, capture everything. That's how it would work prior to 12.2, but from 12.2 onwards, you can specify filters. So for example, with SQL Plan Management, you can say, just capture SQL statements from a specific schema that are parsed in a specific schema, for example, or even SQL statements that match this particular pattern. I can't really overemphasize the fact there's a lot of flexibility here, especially if you're using something like load plans from cursor cache. If you use something like that, you are in a position really to be very selective about what SQL statements you want to take from the cursor cache and store away in a SQL tuning set. Also, a nice alternative trick is, in fact, you can load baselines from SQL sets. So, you know, there's basically so many options there in what you can do and how you can gather plan. But the key thing is to bear in mind is that even if you're pre-Oracle Database 19c, you've got an 11G database, you are in a position to gather SQL tuning sets or capture SQL Plan baselines at that point. And with this in mind, of course, the idea behind this is really to think about, if I capture this and I'm thinking of upgrading to 19c, now is a good time to think about this. So if, for example, you're using 12.1 and you want to go to 19, you are in a position to capture a SQL tuning set today and have that ready for later on when you upgrade to 19C. So let's look at a couple of SPM examples. In this case here, what this means, if you like, so there's a bit of syntax here, but what it means basically is that we capture SQL execution plans. Every one we see, we capture in the SQL plan history. So we're capturing our plans over time. We don't even have to use them. So we set optimizer use SQL plan baselines to false. So all we're doing is capturing them over time. So this, if you like, is an automatic method of gathering plans in advance, for example, of an upgrade to 19C. If you're using 12C and onwards, I would say if you're using this mechanism, what you want to do is to prevent automatic evolution from accepting plans without your knowledge. So an easy way to do that is to set this parameter in SPM that says if auto evolve runs, don't accept plans. Just let it run in the background. You can test plans, tell you which plans are better, which plans are worse, but it won't accept them automatically without your knowledge. So it's a nice way of really, if you want total control over it and you want to use it just to capture plans, this is how you can do it. Now, another thing I want to address here, and I did it, in fact, run this by Mike Dietrich as well, because SPM, and I remember this happening all the time, I think it really gained a reputation of flooding in that essentially what would happen is if you turned on auto capture, it would just fill sysorgs. It would just fill it and fill it and fill it and would become a significant issue. And I think I saw cases as well where it wasn't able to keep up with it wasn't clearing new SQL plan history down. So it was filling up and not being cleared down. So I remember this happening. So I did look into this, and there was one very particular bug that I saw that was fixed to deal with that. And it was true that it was not clearing down new SQL plan history quickly enough. It wasn't keeping up. And which is unfortunate, because I do think, when I thought about this, I thought, where has this reputation come from? Because in light of the automatic SQL tuning set, this idea that it kind of floods as infinitum, it doesn't really make a lot of sense, because we are capturing only repeatable SQL, for example. So in other words, the way that SQL plan management auto capture works is it will only capture SQL that is used more than once. So in theory, it's bind driven SQL. That's the idea. I mean, you can conceive of awkward cases where you've got an entirely unique SQL statement executed twice and then thrown away. I mean, those things are not impossible, but there are ways of mitigating that immediately by saying, you can say how long you want to retain unused SQL plans in SPM. You can set up alert messages. So if the amount of space used by SPM exceeds a certain limit, you can get messages in the alert log. So it's something that you can set up an alert for, in effect. You can see very clearly how much space is being used inside sysorgs. You can purge them manually if you want to. And in fact, there's a MOS note as well, which is a fairly brutal way of getting space back if you really want to do that. It's not something I particularly recommend, but it is a kind of way of getting things back if you really needed to. So I think what I'm proposing here is that the idea of auto capture as a poor solution and flooding sysorgs, I don't think today is relevant anymore. So again, this is something I'm asking for your feedback on, because now looking at cases where we do capture SQL plan baselines, I don't see this happening anymore. But I also see evidence for the fact that it's been dealt with. So, if you know different, let me know about this. But, we're looking as well at things like the size of the auto SQL tuning set, and we know how big that is. And that, as I say, the idea that SPM somehow floods this orcs. To me, it doesn't add up anymore as a true situation. But as I say, get back to me if you know otherwise. So the payoff now, if we talk about why are we going to do all this? So why keep SQL execution plans, for example, prior to upgrade or on an existing system, let's say a 19C system? What is the payoff? Okay. So just to recap on autonomous, it's all fully automated. Okay. You can use in this kind of more manual approach if you want to on autonomous database. That's up to you. We conceived of this mechanism primarily in the context of upgrades. So in other words, it's a mechanism that allows autonomous database to see the plans prior to upgrade. The upgrade occurs, and then we look for regressions and resolve them. Okay, so that's if you like the big driver for this particular solution. So that's autonomous database. But what about when you're on Oracle database 19C and you're not on autonomous and you're not on Exadata? So if you upgraded your database from an earlier release, you are in a position to have been able to capture the execution plans as discussed. So you have been able, for example, to create a SQL tuning set, or you might have created SQL plan baselines, whatever mechanism that you chose to do, you can do that. And whether you've upgraded or not, you can be in a position now of using the automatic SQL tuning set to capture the plans that you're seeing in the Oracle 19C database. So if you are in that position, you are therefore now in a position to address plan-related SQL performance regressions very quickly. The idea is, now there is, of course, there's some assumptions on this that a better plan existed in the past, or let's say there was a great plan that you had prior to upgrade. So that is a basic assumption of this mechanism, of course, but that's why it's aimed at regression. So it's aimed at query performance regression. So a query that was running well yesterday, but today it has an issue. So that's very strongly where it's aimed at. So there is a blog entry that I linked to in this deck that discusses this in detail and also provides you with a worked example. So what we're basically doing here is assuming that you've got a SQL statement, it's been running fine, and now today you notice it has regressed. Now remember, you're not an autonomous database. It's not done, all of this part of it is not done automatically for you. So it does depend on you noticing this has happened. So the first step, if this has happened, is to create a SQL plan history entry for the problem query. So that's, if you like, step one. You can load it from the cursor cache, or maybe you can get it from a SQL set. You basically just create an entry in the SQL plan history for this SQL statement. Next, you set up evolve in a specific way. So you actually identify the SQL handle for the SQL statement that is your problem. You set up, there's a number of ways you can set up this task. Okay, the example I've given you here is one that it says, okay, find me, look inside the cursor cache, AWR, inside SQL tuning sets, try and find me alternative execution plans, you know, that this SQL statement had in the past, for example. Once you've got that, execute the evolve task. So again, link at the bottom for a worked example if you want to see that. Also link from the blog, of course. So really what you're doing is you're saying, I've seen the problem SQL statement. I identify it by its signature or SQL ID or what have you, and then essentially point it at SQL plan management, and then get the background engine of Evolve to go and get the different plans and check them for you. So then step 3 is potentially to generate a report on that. And then it will tell you this plan versus this plan gives you this performance versus this performance. And then in fact, the last step is, if you want to, you can just say implement whatever was recommended in that report or that task. So the idea behind this, I hope you can see, is that it's really a cookie cutter approach. If you look here, all you're really doing is pointing it at the SQL statement and then letting the database figure out the rest. So that's the idea behind it. So you don't have to spend a lot of time kind of weighing one thing against another. You're just looking at, just sort it out for this specific SQL statement. That's the idea behind it. So this, of course, depends on the fact that you've been maintaining a repository or repositories of execution plans from that statement before. In fact, the truth of the matter is that if the SQL statement was always in AWR, then you don't even have had to have captured any additional plans, of course. But the problem with relying on AWR is that a plan can be so good in the past that it was never in AWR. So for those kind of scenarios, you need this additional capture, which is you've either captured it already as a SQL plan history entry in SPM, or you've captured it into a SQL tuning set. And of course, with Oracle Database 19c, that SQL tuning set is being maintained for you. So that is the thing that I'm asking you to consider doing. Look into using the auto SQL tuning set if you're using Oracle Database 19c onwards. Just a quick couple of things I do want to say in addition for SQL plan baselines in general, if you're following this approach, is I do see very commonly SQL plan baselines are chosen and fixed. This is fine. There's nothing wrong with fixing SQL plan baselines, but for me, it has a disadvantage. Well, it has a disadvantage, which is that once you fix the SQL plan baseline, if the optimizer discovers a different plan, it doesn't add it to the SQL plan history. So what that means is that over time, if an execution plan should change, it's not recorded in the SQL plan history. And personally, I think that's a big negative. I think it's a good idea to allow the database to capture alternative plans. You don't have to accept them. And in fact, as I mentioned earlier, you can control Evolve and say, I don't want you to accept any execution plans unless I say so. I specifically want to manage that myself. The option for that is there. So if you're using 12c or above, where Evolve runs automatically in the background, you can just tell it, I don't want you to get involved with accepting plans. You can test them, but don't evolve them. So I would propose again that you don't use fixed, you do allow evolve to run, and that gives you a good body of information that tells you how one plan will perform against another. So it's a nice, I would say it's a very good technique to think about. So if you're currently just fixing individual plans, then maybe reconsider that and think about, why don't I accept the plans I want, allow SPM to capture alternative execution plans over time, and let Evolve figure out which plan is better than the other. And then if I really want to, I am the ultimate arbiter over which plans are accepted and which plans are not. So if I want to be like that, then I've got that option as well. So I just think it provides ultimate flexibility if you work at it in this way. I mean, I'm not arguing that there's no need for fixed. Fixed is something that I know is very commonly used, but think about it. I think another thing that it's kind of a belief that I do see sometime in that fixed is somehow a stronger way of telling the optimizer to use this plan. Fixed doesn't really do that. It tells the database, of course, which plans I prefer. If there are lots of them available, I say, I want you to use this one actually. But you can do that by enabling the SQL plan baselines that you want, and then not enabling other plans so that they're not available for use. So you can achieve the same thing, but I can see the attraction with fixed. You just say, I want this one, forget anything else, fixed. But think about the sort of positives and negatives of that. So I think the negative is that you lose this ability to capture a history of these other plans that are happening over time, which could be better. There's no doubt, over time, if the data distribution changes or something else changes, the data volumes. What if you add an index? You want to use that index presumably. And so what you don't want to do is say, fix this full scan plan, and then you add an index. It's not going to use it, and it's not then going to capture the plan that it sees that's available to it now in the history. It just seems to me that you're really kind of short-circuiting things. So at least if you don't use fixed, you're in a position to say, I want to add this index. I can now actually see the SQL statement plans change. Nothing in the system has changed yet. The plans are being held steady. I can actually see the evolve report. It will tell me now that this index plan is better. And then you can say, accept this recommendation in the report. And it's very clean. So that's my proposal to you, that it should work that way. So in summary, SQL plan management is central to Oracle's autonomous database strategy. So in other words, the mechanism that we are using to control plan regressions and avoid and to repair them quickly is SPM. Is it time to reevaluate plan capture? So is it a good time now to think about capturing your SQL statement execution plans? I think it's something to consider, because it leads you smoothly into the future, for example, if you do that. That's my contention here. You can use SQL plan management, auto capture, or actually my preferred is bulk capture. So in fact, you're selective about what you want. You create maybe a SQL tuning set based on filters, or you capture even from AWR perhaps. That's better than nothing else. So I like the idea of bulk capture the most. I think you take it from, for example, the cursor cache directly. It's hugely flexible there. You can just select from the cursor cache and decide what you want and what you don't want. It's very straightforward. You can, of course, capture plans in SQL tuning sets. And so once you've done that, you have the ability then to repair SQL performance regressions much more quickly. Well, I'm assuming more quickly. I don't know how fast you are in general, but I think it gives you a good mechanism for fixing plans quickly. So there are plenty of options all the way through from 11G onwards to do this. And I think if nothing else, historic plan capture, in addition to AWR, is a useful tool for addressing performance issues. So yeah, so my proposal broadly is look to the future and what we're doing in autonomous. If you want to take advantage of that in future or follow that pattern, then that is available to you today. So you can, start to make use of these tricks, so to speak, that we have, this sort of functionality that we've built in. More information. I tend to blog about this quite a lot. You can IM me on VLDBB, for example, or email me if you want. As I say, I'm very much looking for feedback on this, about what your thoughts are. And then my plan is actually, I was holding back the blog post for this particular event because I thought actually if anyone's going to come back with feedback, it's you lot. So I hope you will. There's the upgrade blog, of course, which I'm sure you're all aware of. Always bear in mind the license guide. If there's any doubts about what's available where, there is the license guide, which will tell you exactly what features you can use and where. I tend to like to direct you to that rather than getting too much in the details of verbalizing what's available where, because I think it can cause confusion. I think what I prefer to do is say, go to the license guide and look there, and that is the single source of truth. So I try really to try and follow that pattern, really, that the license guide is where to go for all kind of questions over what's currently supported. Okay. So I think that is everything I've got, and we've got plenty of time for questions by the looks of things. So let me open up the chat. Hopefully, if I can do that.
So there is one question that was in the chat before, and I took a note so you have the context. You were on slide 12.
Oh, yes.
About the automatic SQL tuning set, the on and off settings.
Yeah.
And a question from Julian was, is it also on in autonomous JSON database?
Autonomous JSON database, I don't know. I'm sorry. The reason I don't know is because I'm not involved in the ownership of that database, so I'm not sure what they've chosen to do. I must admit. So the way to check is go to the note. It will tell you then how you can look specifically on what the settings are. And whether things on or off, and that kind of information is available, but I couldn't tell you whether it's on by default in the JSON one. I don't know. I do know ATP and ADW, and it's on by default currently. The thing is about stating that is sometimes the defaults do change, as I'm sure you're aware. So again, it's something that you always have to be a little bit careful of and look what Autonomous is currently doing. But currently, it's all on. Okay, but on the JSON, I'm not sure. Right, more questions.
There is one in the Q&A. If you
Oh yeah,
see
got
the
it.
Q&A,
I can see the Q&A. Ah, hi, Christian. So in pre-19C environments, you are advised to automatically capture SQL plan baselines. So actually, let me make it clear. I'm not, in fact, really advising one thing over another for starters. I think it's very much a matter of choice and preference. So the question is, asking, I definitely don't want to say capture SQL plan baselines in preference to a SQL tuning set. It's a bit more nuanced than that. I think that the choice is more to do with what you have, what you prefer to use. And so I think, yes. So Christian says, why not advise create a SQL tuning set? And the answer is, yeah, do. So because from a technical perspective, I don't necessarily see a huge amount of difference in the general case between capturing your plans in a SQL tuning set versus SQL plan management. But however, I think all of you will have an opinion that you will say, I would prefer to do X or Y. So I don't think it's for me to say you should do X or Y. That is up to you. I do think either mechanism is okay. If you are looking to kind of fit in line with Autonomous and follow that approach, then that obviously then points you to use the SQL tuning set. So let me just make sure I've got, are there any licensing reasons? No licensing reasons for one versus the other, no. So you can choose which you prefer. So you've got different options. You can capture plans in SQL tuning sets, you can capture them in SQL plan baselines, you can capture them in a SQL tuning set and export and import them to different databases. You can load them into SQL plan baselines. All of those things are open to you. If you want a simple answer, the pattern that follows Autonomous database, you capture in a SQL tuning set, and then you just maintain that. And that's your kind of, your source of plans becomes a SQL tuning set. And then if you need to fix a plan regression, you then use SPM to figure out from that SQL tuning set what plan to take. So I think that's the summary of what I would say. So I'm not necessarily recommending one approach over another, but if you look at the pattern that Autonomous uses, it's that. It creates a SQL tuning set, and then you use that as a source of plans to fix plan regressions. Okay. Has that answered your question, Christian? Okay. So yeah, I sometimes worry with presentations that I give the wrong impression that I'm recommending one thing over another. I think really what I want to say is this is very much a presentation that shows you what we have chosen to do. And the idea behind it is that it gives you a heads up, and that you may want to follow that. At least you have an awareness, if you like, of where we're going with the way that we design these features. And you now have the choice to kind of piggyback on that and follow that pattern. Okay, that's really the idea behind it. And what I do like about it is that it's something you can do about today. So, you know, for those of you that are on 11G or 12.1 or 12.2, there are a lot of options now if you're thinking of going to 19C. You know, I've lost count the number of times that you've got a regression that's seen post-upgrade, and there's just no information on what was happening beforehand. You know, I'm sure we've all been there, and that's such a tragedy, because if we have that information from what was there before, resolving these problems can be incredibly quick and easy. Making the assumption, of course, that we have, you know, bind-driven SQL, basically. You know, if we've got a system that's highly dynamic, you know, the rules change a little bit. It's a little bit harder, of course, but in the general case where we've got bind-driven SQL, we've got a real ability here to do something about regressions really quickly, to get them, you know, and get, you know, if you want to pursue a bug or understand the underlying reason why some plans have changed, that's fine. But I think this enables you to get that sort of problem off the critical path, so you're not dependent on that SR or what have you being sorted out within the next, you know, 2 hours or something. We're in a position here to be able to fix things just, you know, like that. So, you know, regarding upgrades, and again, I spoke to Mike Dietrich about this, is that, you know, think about why don't we keep our plans pre-upgrade, look at doing that. And also other things I thought of doing was you can do, of course, metadata exports, keep the metadata prior to upgrade. And what I mean by that is keep the DDL, keep the statistics as they were prior to update. Take an export of that. That's something, again, that's incredibly useful in diagnosis of issues. At the end of the day, I'm not sure diagnosis is necessarily the way ahead. You know, we do provide mechanisms to resolve these things quickly, provided, again, you're using bind-driven SQL, you know. So you don't necessarily have to get into diagnosis, but if you anticipate you want to, then I think there's things you can do in advance that really, really help that a lot. Okay. Any more questions?
I didn't see any other question in the chat or the Q&A. So people, if you have something to ask, you have a bunch of time now as we have a little break.
Yep. So I'll hang on the line then in that case.
Yeah. And in the meantime, thank you very much for your presentation. It was really nice to have you with us.
No problem. Thanks for the invite. It was good. Thank you.